Hello everyone. What we'd like to do in this section, or in this video, is we want to try to simplify trig expressions. So oftentimes you can have this trig expression that looks really ugly and really messy, and what we want to do is we want to use all those fundamental identities we learned in the last video to massage these expressions just to make them look prettier. So let me show you what I mean. These type of exercises, if you love puzzles, you're gonna love chapter 7. There's a lot of algebraic manipulation, a lot of canceling, and a whole lot of fun. So when simplifying expressions, it's kind of hard for me to kind of make a list of exactly what to do, but I can kind of give you some guidelines on things you might want to try. So as some guidelines, usually one thing to always try and do, we don't always have to try this, but usually a great go-to method is to write every single trig function in the expression in terms of sines and cosines. That was one of the big things we learned in the last video, or a big comment I tried to make is any trig function can be written in terms of sines and cosines. So write everything in terms of sines and cosines. Okay. From here, I'm going to kind of loosely say that we want to simplify. And what do I mean by simplify? What I mean is we want to make sure that there are no common factors that can be canceled. So I'll say cancel. We'll want to cancel common factors. And we're also, whenever a fraction presents itself, we'll want to find a common denominator. Find common denominator. Okay. And 3. Now, once, pretty much at this point, going through the exercise, everything will be in terms of sines and cosines. It may be convenient from here to actually rewrite things back into another trig function. So let's say at the end of the day, when we're simplifying, the result turns out to be 1 over sine. Everything's in terms of sines. What you're going to want to do is, well, 1 over sine is we already have a nice name for that. 1 over sine is the same thing as cosecant. So you might want to switch back to other trig functions. So let's say, if necessary, let's say, if necessary, write your result in terms of other trig functions. And again, what I'm kind of meaning here is if you end up with something like 1 over cosine, maybe you simplify something and it turns out to be the same thing as 1 over cosine, well, go ahead and just write this as secant of theta. So that's what I'm kind of meaning here in step 3. Let's just do a ton of examples. The rest of this video is just example after example after example. So if I kind of forget to tell you to pause the video and try these on your own, make sure to do that. The best way to learn is trying these on your own, seeing if you can get them. If you get stuck, watch the video. And kind of see where maybe where your mistakes were. Okay, let's start with some kind of simple examples. So our first example is, let's go ahead and simplify. So for all these examples, the direction is to simplify. So simplify. Let's say we have tan of theta times cosecant of theta. Okay, we want to simplify this. Right now this looks a little ugly, but let's clean it up. Again, maybe try pausing the video and see if you can clean this up on your own. Okay, let's try it. First thing I'm going to do here is I'm going to write everything in terms of sines and cosines. So let's write this. Tangent of theta is the same thing as sine of theta over cosine of theta times, and cosecant is the same thing as 1 over sine of theta. Okay, we could now, hopefully you can see that we could cancel these signs out. If you don't like that, we can multiply these fractions together. This is the same thing as the sine of theta times 1 all over the cosine of theta times the sine of theta. Well, we have a common factor of sine of theta, so those will cancel out. So also remember, we still kind of have this times 1 that's right here. So we'll now have a 1 over the cosine of theta. So we've kind of simplified, we've canceled these common factors. Now what we're going to want to do here is we have a 1 over cosine. We have a great name for this type of function. 1 over cosine is the same thing as secant of theta. So the whole time, this really ugly thing we have here is really just the same as secant. Much prettier. Much prettier. Okay, that's the answer. How fun is that? Okay. Let's try another one. I'm going to go ahead and erase this. Okay. So secant. Let's say we have secant of, how about secant of x all over cosecant of x. Okay. Go ahead and pause the video and see if you can clean this thing up. Okay, let's do it. First thing I'm going to do is I'm going to write this in terms of sines and cosines. So secant is the same thing as 1 over cosine of theta. Okay, and secant is the same as 1 over cosine of theta. Cosecant is the same thing as 1 over sine of theta. So what we have here is we now have a fraction divided by another fraction. So what are we going to do? We're going to flip and multiply. So this is equivalent to 1 over the cosine of theta times the sine of theta all over 1. So I guess this is really just saying 1 over cosine of theta divided by 1 over sine of theta. So remember, when we divide fractions, we flip and multiply. Well, we can multiply straight across. So this is the same thing as sine of theta all over cosine of theta. So I guess the simplifying came from is when I write this in terms of sines and cosines, we have a complex fraction. When we have a complex fraction that is not simplified, a complex fraction just means that there are fractions within fractions. We don't like to have fractions within fractions. We want to clean that up, just like this here. We want to flip and multiply. So when we do that, we get sine over cosine, but sine over cosine, I hope you believe, is the same thing as tangent of theta. So this whole time, this little secret, secant over cosecant, it's like, come on, that's tangent. Come on, that's just tangent. Don't trick me, just tell me your tangent. This is like tangent on Halloween. This is like tangent on Halloween. It's wearing a costume. Just tell me your tangent. Just tell me that you're tangent. Looks like I switched my variables halfway in between. Here, there. I should have all these as x's. Should have all these here as x's. You get so used to using theta, you know. I try to give you diverse examples with other variables, and then even me, I kind of resort back to using what I'm always used to, the thetas. But just a variable change. Here we go. Beautiful. Okay, let's go ahead and try this next example. Go ahead and pause the video, give it a shot on your own. Okay, let's do it. First thing I'm going to do here, I think there's a couple of approaches we could take here. What I'm going to do is let's write this in terms of sines and cosines. So we'll have a 1 plus, now you could remember the even and odd properties of cotangent and cosecant, but if you just remember the even and odd properties of sine and cosine, you could kind of wait to do the even and odd property. So cotangent is the same thing as cosine of negative x all over sine of negative x all over, let's see, cosecant, that's 1 over the sine of negative x. Okay. Let's see what we can do here. Well, this is the same thing. Okay. We have a 1 plus, looks like we have a cosine of negative x all over the sine of negative x, okay? Since we have a fraction divided by a fraction, I can flip and multiply. So how about times? This will be a sine of negative x all over 1. Okay, be a little bit careful. We can't just kind of cancel these signs right here because in parentheses I have a 1 plus. We need to be a little bit careful. But what we can do is I can distribute this 1 over sine into these parentheses. Okay, so I'm going to have a sine of negative x times 1. So how about we write this as we could write this as a sine of negative x plus, well, when the sine of negative x sits here, these sines of negative x's will cancel, and I'll just be left with the cosine of negative x. Okay, now it's oftentimes not, when we're simplifying, usually we don't like to have negatives on the insides of trig functions, so we want to think about the even and odd properties of sines and cosines. Well, I hope you believe that sine is an odd function, so the negative can move out front, so this is the same thing as the negative sine of x plus, well, remember that cosine is an even function, so this is just going to be cosine of x. Sine is odd, cosine is even. So what we have here is this is equivalent to negative sine of x plus cosine of x. It doesn't matter how you write it. It'd be totally fine for you to write it like this. However, I think this looks nicer if we write it as, how about, this is the same thing. This is the same thing as cosine of x minus sine of x. So this would be cosine of x minus sine x. I would think that this looks prettier to my eyes. This looks prettier to my eyes. I would say this is much simpler than what we have written right here. Okay, just for fun, let's say maybe you didn't want to take this approach. Just kind of show you a little bit of diversity. What else could we have done here? Well, since I have a sum, and I'm taking the sum and I'm dividing it by a cosecant, I have to divide all the pieces by cosecant. So maybe as another approach you could have taken here, is that this is the same thing as 1 over cosecant of negative x plus cotangent of negative x all over cosecant of negative x. We could have taken this approach here. From here, we could have realized that 1 over cosecant is the same thing as sine of negative x. Plus, okay, what are we going to do with this? Here, we could clean this up. Here, you might want to, how about we do this? This is the same thing. You know, there's a couple ways you could say that this is cosine over sine divided by 1 over sine. How about I think about this as cotangent of negative x times a 1 over cosecant of negative x. Here I've just kind of split up the fraction multiplication. If you'd like, you could think that this is all over 1. I've kind of broken it up. So here we'd have sine of negative x plus, well, how about we write this now in terms of sines and cosines? So cotangent of negative x is the same thing as cosine of negative x all over sine of negative x times, well, 1 over cosecant is the same thing as sine of negative x. Now, what do you know? These cancel each other out, and we're left with sine of negative x plus the cosine of negative x. Now we could use the even and odd properties. Sine is odd. I can move the negative out front. Negative sine of x. Cosine is even, which means a negative on the inside does not affect the function. So here we have the same thing, cosine of x minus sine of x, or negative sine of x plus cosine of x. So this is another approach you could have taken here if you didn't want to start by writing everything in terms of sines and cosines. So something fun you could try. Okay, again, if you don't like, if you just want to stick with writing things in terms of sines and cosines and simplifying from there, you can always do that. Okay, let's do another one. Okay, let's say we have how about a 1 minus sine squared of x all over, how about the cotangent of x? Okay, pause the video and see if you can clean this up here. Okay, let's do it. The first thing I'm going to notice here is you could definitely write these all in terms of sines and cosines. But the big thing that's just yelling at me is I have this 1 minus sine squared. That should be tingling your brain saying, that's almost like a Pythagorean theorem kind of thing going on here. I hope what we could see here is that Pythagorean identity, sine squared of x plus cosine squared of x is equal to 1. If you subtract sine squared from both sides, we have that cosine squared of x is equal to 1 minus sine squared of x. So if you're ever playing around with these and you see like a sine square, a cosine squared hanging around somewhere, you're probably going to want to be thinking about Pythagorean identities. And that's what this example here is doing. So 1 minus sine squared is the same thing as cosine squared. So that's a great first observation. All over the cotangent of x. Okay, from here you could write things in terms of sines and cosines. So we could write this as cosine squared of x all over, let's see, cotangent is the same thing as cosine of x all over sine of x. Okay, we could think about flipping and multiplying this here. Think about the cosine squared of x as this is all over 1. So I'm taking this fraction and dividing it by this fraction. So here we get a cosine squared of x over 1 times we have a sine of x all over the cosine of x. Okay, this is cosine squared, so I have 2 copies of cosine here. One of those will cancel with the cosine in the bottom. So what we have here is this is equivalent to just cosine of x times sine of x. And I would say that this is a much simpler expression than what we have right here. This is equivalent to sine, or, well, order of multiplication doesn't matter. Cosine of x times sine of x. Okay, so here we have it. This is the simplified version here. Okay, what else could we have done? I mean, maybe we could have thought from here that 1 over cotangent is the same thing as tangent. This is the same thing as cosine squared of x. 1 over cotangent. Well, 1 over cotangent is the same. How about I show a lot of gory detail? If I undo this fraction multiplication, this is equivalent to this. This is the same thing as cosine squared of x times tangent of x, since 1 over cotangent is the same thing as tangent. But tangent is the same as sine over cosine. So I'm still going to get that cancellation, and we're still going to get cosine times sine. Fun. Okay. Let's do some more. Let's do some more. Okay. Let's start making them a little bit spicier. Okay. How about the cotangent of theta all over, how about the cosecant of theta minus the sine of theta? Go ahead and pause the video and see if you can clean this example up. Okay, let's do it together. In this case here, I think it's going to be nice for us to write everything in terms of sines and cosines. So cotangent is the same thing as, what is this? Cosine. This will be cosine of theta all over sine of theta. All over, let's see what we have here. Well, cosecant is the same thing as 1 over sine of theta minus, how about just a sine of theta? So I've written everything in terms of sines and cosines. From here, we need to clean up this complex fraction. Be careful, we cannot just kind of flip and multiply the bottom, because the bottom is not a solid fraction. What we need to do in this example is we need to find a common denominator. We actually need to add the fractions in the denominator first to get a solid fraction, then we can flip and multiply. We need to simplify this complex fraction. Maybe I'll show you 2 different ways you could clean this up. How about way 1? Way 1 is to find a common denominator. So, if this is over 1, how about we think of this as a multiplying cleverly by 1, best trick in the math book. We'll hit this with a sine of theta over sine of theta. So what we'll have here in the numerator, we'll have still have that cosine of theta all over that sine of theta. And in the bottom, well, they'll both now have a common denominator of sine of theta. So now we'll get a 1 minus, we're now going to get a sine squared all over our common denominator of sine of theta. Okay, so this is great. I've cleaned this up. Now I can take this bottom and I can flip and multiply. Okay, so this is now the same thing as cosine of theta. I'm trying to stand in front of the board, or the camera and the board, whatever. Cosine of theta times sine of theta times, we'll flip and multiply. So this is now what? Sine of theta. We'll get a sine of theta all over a 1 minus sine squared of theta. So we're flipping and multiplying. Okay, a few great things that are going to happen here. Right? There's a lot of canceling that's going to happen, but I don't know if you can smell it, but I can smell it. That smells like cosine. This smells like cosine. The Pythagorean identity. 1 minus sine squared is the same thing as cosine squared. Whenever you see those trig functions being squared, you got to think about those Pythagorean identities. I think we saw this in the last example. Sine squared of theta, sine squared plus cosine squared of theta, that's equal to 1. So 1 minus sine squared of theta, just subtract sine squared from both sides, is equal to cosine squared of theta. 1 minus sine squared, the same thing as cosine squared. How fun. So here we have cosine of theta all over sine of theta times, we got that sine of theta over here. 1 minus sine squared is the same thing as cosine squared of theta. Now, all this canceling is going to happen. This sine cancels with this sine. This copy of cosine cancels with one copy in the bottom. So what we're left with is still a 1 over cosine. We still have a 1 over cosine of theta left. 1 over cosine of theta left. Well, what's 1 over cosine? What's 1 over cosine? Man, that's just secant. That's just secant of theta. Wow, why'd you have to trick us? Why'd you have to trick us? Hey, you crazy expression. Hey, you crazy expression. Why don't you just tell me you're secant? Why didn't you just tell us you were secant all along? Come on. Come on. This is just secant of theta. This is just secant of theta. Okay, how cool. Okay, maybe another approach for this one. I would still recommend, getting to this complex fraction. But instead of finding a common denominator in the bottom, and then, adding these fractions, flipping and multiplying, another way you could have cleaned this up is by clearing the fractions. And if I'm looking at all these denominators, we'll have a sine of theta, and a 1. What's the least common denominator? The least common denominator is a sine of theta. So we could have cleverly multiplied by 1 into the larger fraction. Sine of theta into the big numerator over the sine of theta into the big denominator. Okay, don't forget your parentheses. Be paranoid with parentheses. Okay, now when I multiply this in, sine of theta, when this multiplies in, those sine of thetas will cancel. I'll just be left with a cosine of theta in this numerator. Okay, this sine of theta is going to go ahead and distribute into here. Sine of theta times a 1 over sine of theta, those will cancel, so I'll just be left with a 1 minus, we're just going to get a sine squared of theta. This was nice and clean, just multiplying the big numerator by sine and the big denominator by sine. I'm still cleverly multiplying by 1, but now we have that this is the same thing as cosine of theta. 1 minus sine squared is the same thing as cosine squared of theta. Oh, this is so much fun. Let's cancel one of those. I still have this times 1 here. So this is still 1 over cosine of theta, which is all just secant of theta. Secant of theta in disguise. Okay, let's do some more. Okay, let's try this one. Let's say we have a 1 plus, how about a sine of y all over a 1 plus cosecant of y. Okay, go ahead and pause the video. Go ahead and pause the video and give this one here a shot. Get a better, maybe a little juicier of a black marker. Okay, let's do this one here. Okay, a very common mistake I see some students make here is I do have a 1 plus sign. This is even if it was 1 minus, a 1 minus sign. This isn't the same thing as cosine. This is not the same thing as cosine. There's nothing being squared. There's nothing being squared, so I'm not even going to mess around with Pythagorean identities. There's nothing being squared. So the only thing I can really see to do here is to write everything in terms of sines and cosines. So how about we write this as a 1 plus a sine of y all over a 1 plus, well, let's see, what is cosecant? Well, that's the same thing as 1 over sine of y. Okay, now from here, there are two things that we can do here. You could go ahead and find a common denominator in the bottom and flip and multiply. How about we do that version really quick? So one option would say this is 1 plus sine of y all over, well, this 1 here, think of this as a sine of y over sine of y. You know, write this 1 as a sine of y over sine of y. Now when I add those, when we add these, this will just be a sine of y plus 1 all over a sine of y, our common denominator of a sine of y. Okay. So now you could think, you know, I try to make this bigger. I try to make this fraction bar larger. Okay. Well, this whole 1 plus sine of y in the top, think of that as over 1. And now I can flip and multiply. So this will become a 1 plus a sine of y all over 1 times, reciprocate the bottom. This is the same thing as sine of y all over a 1 plus sine of y. Let's get out of the way. And look, these cancel. Isn't that fun? Isn't that fun? It's all just sine of y. It's all just sine of y. Everyone's just tricking us here. This is just sine of y. This is Halloween in May. This is Halloween in May. Okay, fun. Okay, this is all sine of y. Much simpler. This looks so much nicer. Okay, what could have we done different here? Kind of, a little bit similar to what we did in the last example, is instead of, I guess, finding the common denominator in the bottom, and flipping and multiplying, what we could have done is we could have, the only denominator I see here is a sine of y, so we could have multiplied the big numerator by sine of y and the big denominator by sine of y. I'm still cleverly multiplying by 1. Okay, don't forget your parentheses. Okay, now let's see what happens if everything distributes in. Let's see if this would have been any cleaner at all. Well, let's see here. I'm actually going to not distribute in the top one. Let's leave this as how about a 1 plus sine of y. Okay, and I'm going to keep the sine of y. So I didn't distribute in the sine of y into the numerator. I just kept it in terms of multiplication. All over, but I want to distribute this sine of y in because I want to get rid of this fraction. Well, this is the same thing as sine of y plus sine of y over sine of y, which will just be 1. Okay. You think I kind of saw the times 1 here. Well, order of addition doesn't matter, so these are common factors. These can cancel out, and we're still left with sine of y. How fun. So either way, this is sine of y in disguise. Okay, let's do another one. Ooh, this one looks spicy. This one looks spicy. Get your milk ready. Get your milk ready. Okay, let's say we want to simplify. Let's say we want to simplify a 1 all over a secant of x minus a tangent of x, and then we want to subtract a 1 over secant of x plus the tangent of x. Oh, this looks spicy. But who doesn't love, you know, a little spice in life. A little spice in life. Go ahead, pause the video, give this one here a shot. Okay, let's do it. I mean, what are we going to do here? I mean, I guess there are a couple approaches here that we could take. There are a couple approaches. Okay, maybe we'll do it in two different ways. One thing we could do right off the bat is find a common denominator if you wanted to. Okay, let's actually not take that route first. Let's first stick with what we've been doing before. Let's write this in terms of sines and cosines and see where that leads us. So let's focus on each of these pieces separately. Let's look here and see what we can do with this. Okay, well, this is a 1 all over. Secant is the same thing as what? A 1 over cosine of x. Okay, tangent is the same thing as sine of x all over cosine of x. Okay, well, that is like incredibly convenient. You already have a common denominator of cosine. Oh, sweet. This is just 1 all over a 1 minus sine of x all over a cosine of x. Well, I hope you believe if this is a 1 over 1, I can just flip and multiply. Or 1 over this is just the reciprocal. This is equivalent to just cosine of x over a 1 minus sine of x. Okay, well, we've cleaned up this piece here. And if the directions just asked us, if they just asked us just to simplify this piece, this is as simple as we could get it. There's nothing more really nice we could do with this. There's no common factors we can cancel. It's in terms of sines and cosines. This is great right here. Notice that there's no Pythagorean identity I can do here. Don't be convinced. Don't be confused. 1 minus sine is not the same as cosine. 1 minus sine squared is the same thing as cosine squared. There's no squares here. Don't use the Pythagorean identities. Okay, well, let's see what what's this side clean up to. Okay, well, the only difference is, you know, here we had a minus, here we have a plus. This is 1 all over. We're still going to get a 1 over cosine of x, 1 over cosine of x, plus a sine of x over cosine of x. Okay, so this is a 1 all over, this is a 1 plus sine of x all over cosine of x. Okay, we can just flip and multiply. This is the same thing as cosine of x all over a 1 plus a sine of x. So I've kind of cleaned up both of these pieces here. Okay, so what do we have to do? We have to subtract these two pieces. We have to subtract these two pieces here. And I'm going to write it up here so we have a little bit more room here. This is not simplified because I still have a fraction that we need to subtract. Okay, I'm going to bring all this up. So after a little bit of this work here, what we have is we have a, this turns out to just be the same thing as cosine of x over a 1 minus sine of x. Okay, minus, what do we have? We have a cosine of x over a 1 plus sine of x. All right, so we need to find a common denominator. So a common denominator, in this case, will be the product of these two denominators. So we need to hit this one. We need to hit this one with a 1 minus sine of x all over a 1 minus sine of x. Okay, and over here, we need to hit this one. We need to hit this one with a 1 plus sine of x all over a 1 plus sine of x. So I'm just cleverly multiplying by 1 so I have a nice common denominator. Okay, what are we going to get here? And we're also going to need to be a little bit careful with parentheses. Okay, so we're going to get a 1 plus a sine of x times the cosine of x, and we're going to be subtracting a cosine of x times the 1 minus sine of x. Okay, all over our common denominator of a 1 plus sine of x times a 1 minus sine of x. Okay, now what we're going to be doing here is just pretty much foiling everything out. I'm actually not going to, it'll be, well, let's notice here that this denominator actually cleans up really nicely if we are to expand this. Okay, you should kind of notice this is almost like a difference of squares factoring pattern, but if you don't know this, and I'm just focusing on this denominator, if I multiply this out, that's a 1 times 1, so we get a 1, or how about a 1 squared? We're going to get a 1 times negative sign, we'll get a minus sine of x, but then we're going to get a plus a sine of x, and then we're going to get a what? A minus, a sine times a sine, we call that sine squared of x. So these cancel. And really what we have in the denominator is the same thing as 1 minus sine squared. So this is the same thing. In the bottom is a 1 minus sine squared of x. Well, hopefully we've seen this a few times now. 1 minus sine squared is the same thing as just cosine squared. Sweet. Now notice here, now I'm thinking about Pythagorean identities because I'm seeing a sine being squared. Beautiful. So that's what I'm gonna rewrite this denominator. We just cleaned up this denominator piece. That's all the same thing as a cosine squared. This is the same thing as just a cosine squared. That was fun. Okay. Well, now what can we do? Okay. Well, one thing we could do here, if you would like, is you could definitely distribute in this cosine in here, and you could distribute the negative cosine into here. But, I mean, the big thing that's screaming at me right now, at least, is I see I have these kind of two terms here, and they each have a common factor of cosine. We could factor that cosine out and cancel one of these. So this turns out to be the same thing as a 1. So if you can't see that, I'm taking this copy of cosine and this copy of cosine. I'm factoring a copy out front, and then I can cancel with one of them in the denominator. So this is a 1 plus sine of x minus, don't forget the parentheses still need to be there, a 1 minus sine of x. Okay, all over. Now I only have one copy of cosine because I canceled them out. So you kind of think I'm canceling one copy from the bottom. Factoring these out, canceling one from the bottom. Cosine of x. All right, what to do now? Well, the only thing I can think to do is to subtract these. So let's go ahead and distribute this minus sign into the parentheses. So when I subtract, multiple pieces, I got to subtract all the pieces. So I'm going to be subtracting a 1, and then I'm going to be subtracting a negative sign, so that's going to make this a plus. So I'm distributing in that minus sign, which is going to flip the signs. Okay, and these parentheses aren't needed. We kind of just get rid of those. Okay. So I have 1 plus a sine minus a 1 plus a sine. Well, I guess notice that these ones, I have 1 and I'm taking away 1. So what are we left with just in the top? I have a sine x plus another sine x. I have 2 sine x's. I have 2 sine of x all over cosine of x. But this is the same thing, and showing this is the same thing as 2 times tangent. You could think of this as the same thing as 2 over 1 times, I'm showing gory detail here. This is just kind of breaking up this fraction multiplication. This is just the same thing as 2 times the tangent of x. Oh my goodness, this whole time, this mess was just the same thing as 2 times the tangent of x. It took a little bit of work, but we got there. Let me show you a different approach for this problem. Maybe you didn't want to write everything in terms of sines and cosines. Do I know if this next approach I'm going to do here is going to be easier? No. But we're going to just see if anything nice happens. Okay. What could we have done right off the bat? Right off the bat, we could have maybe noticed that I could have found a common denominator right from the beginning. So this will be the same thing. This will be the same thing. I need to hit the top one here. I need to hit this top one here with what? A secant of x plus a tangent of x all over a secant of x plus a tangent of x, if you'd like. Just multiplying this piece by this clever one. Over here, I would have to multiply. So we don't know it's 2 tangent yet. We're trying to show them we're going to get to the same answer just with a different approach. Well, we could have hit this one with a secant of x minus a tangent of x all over a secant of x minus a tangent of x. Okay, what would happen? Well, we would be left with a secant of x plus a tangent of x, okay? And now I would be subtracting, don't forget your parentheses, we would be subtracting a secant of x minus the tangent of x, okay? All over our common denominator of a secant of x plus a tangent of x times a secant of x minus a tangent of x. So here, instead of writing everything in terms of sines and cosines, maybe what I decided to do here instead was just, I don't know, just add the fractions right off the bat. Well, maybe something nice will happen here. And I'm seeing a few things that are going to happen nicely. At least in the numerator here, I can distribute this minus sign in. So it'll be a minus secant and now a plus a tangent. Well, which is great because I have a secant of x, a minus a secant of x. So right off the bat, these are canceled. Well, that's fun. And I have 2 tangents. I have tan of x plus a tangent of x. So I already have that 2 tan, which is great, which must mean that somehow what we have in the bottom here must be 1. Well, let's play around with it and see. Well, what do we have here in this denominator? Okay, focusing just on the denominator. Well, if we expand this, I'm going to get a secant squared plus a secant squared times a secant squared. So we'll get a secant times a secant, that's secant squared of x. Okay, I'm going to get a secant times a negative tangent, but I'm also going to get a plus a tangent times a secant, so the O and the I in FOIL will cancel each other out. And then we're just going to be left with a minus. We're going to be left with a minus tan squared of x. So this is me just foiling out the denominator. Okay, this is like a difference of squares pattern. Here, this squared minus this squared, that would factor to sine plus tangent times sine minus tangent. This is really just the difference of squares. Okay, well, what can we do with secant squared minus tangent squared? Well, gosh, I'm seeing those squares, so for me, I'm just thinking to myself, hey, Pythagorean identity. Now, either you remember the Pythagorean identity with tangents and secants, or you just, I don't know, I just remember that sine squared of x plus cosine squared of x is equal to 1. Okay, I need tangents to show up. So if we divide everything let's divide everything by what? By cosine squared. So this is my trick for memorizing these. Divide everything by cosine squared of x. So what do we have here? Well, this is just tan squared of x plus 1 is equal to what is this? This is secant. This is secant squared of x. Oh! Subtract. I want to get a secant of x minus tan of x. Subtracts tan of x, tan squared of x from both sides. So this just says exactly what we were hoping it would be. That 1 is equal to secant squared of x minus tan squared of x. So yeah, this is just 1. So the numerator is tangent plus another tangent. So we still get the same thing as 2 tangent of x over 1, or just 2 tangent. Notice we got the same exact answer. Okay. So what did I hope to show you with this example? That there's, I guess, mainly multiple ways you could do things. If you didn't like how I approached this problem here, just stick with writing everything in terms of sines and cosines, and you won't go wrong. Here I just thought maybe it'd be fun to just find a common denominator without writing everything in terms of sines and cosines. Either way, we got the same answer, 2 times tangent. Okay, let's see. This looks like I have another couple examples that we could try. Okay, what if we have something like this? How about we try to clean up? How about a 1 minus tan squared of t all over a 1 plus tan squared of t. How about all plus 1? Okay, go ahead and pause the video and give this one a shot. Okay, let's go ahead and do this. So right off the bat, I mean, Pythagorean identities are screaming at me to try to use here. I also have this plus 1, so we need to make a mental note here that we will have to add fractions. So whether you want to use a Pythagorean identity now or later is all up to you. Again, you could write everything in terms of sines and cosines right off the bat, but I think at least what I'm going to do here is I think I'm just going to add the fractions right off the bat. This isn't necessarily the right approach, it's just a approach. How about instead of a 1, how about we think of that 1 as a 1 plus tan squared of t all over a 1 plus tan squared of t. So I'm now going to be adding the fractions. And this will be nice because I'll have a 1 minus tan squared plus a 1 plus tan squared. The tan squareds will cancel. So what are we going to get here? This is going to be the same thing. I'll write it all up. This is 1 minus tan squared of t plus the 1 plus the tan squared of t all over our common denominator of a 1 plus tan squared of t. Here I have a negative tan squared plus a positive tan squared. Those cancel each other out. I have a 1 plus a 1, that's just 2. So we now have a 2 over a 1 plus tangent squared of t. Now, from here, you could definitely just write things in terms of sines and cosines, add fractions, flip, multiply, play around with this. But I'm going to say, man, this just smells a whole lot. This smells a whole lot like a secant squared. I think, what do we see? We have that tan squared of t plus 1 is equal to secant squared of t, the nice Pythagorean identity. So this denominator here is the same thing as secant squared. This is 2 all over secant squared of t. But this is 1 over secant squared. This is the same thing as 2. Well, 1 over secant squared is the same thing as what? This would be cosine squared of t. And here we have it. This is the answer. 2 times cosine squared of t. This whole ugly thing, the whole time, was just 2 times cosine squared of t. Okay, fun. Okay, let's see. Looks like I have another one that looks like something fun we could try. Okay, let's say we have, how about secant of t minus cosine of t. How about all over a 3 times the tangent of t times the sine of t. Okay. Go ahead and pause the video and give this one here a shot. Okay, let's go ahead and do it. For this one right here, it's screaming at me to write everything in terms of sines and cosines. Okay, so a secant, that's the same thing as, how about 1 over the cosine of t minus the cosine of t. Okay, all over, okay, what do we have here? This is the same thing as 3. Tangent is the same thing as sine of t all over cosine of t times another sine of t. Okay. So there's a couple things we could do here. I guess we could clean up the bottom and we can flip and multiply. What I want to do here in this case is, multiplying everything together, flipping and multiplying into the numerator. I think the approach I'm going to take here is I see a denominator of cosine. I see another denominator of cosine. I want to clear these fractions. I'm going to hit the top. I'm going to hit the top with a cosine of t, and I'm going to hit the bottom with a cosine of t. You definitely could have taken a different approach, but that's what's fun in math is just, as long as you're doing things, that aren't illegal, you'll get to the right answer. Okay, so now this cosine of t will distribute into these parentheses, and here these cosine of t's here will cancel. So in the top, we're going to be left with a cosine of t over cosine of t. We'll get a 1 minus. Now we're going to get what? A cosine squared of t. Ooh, that's making me happy. That's making me happy. That smells a lot like a sine squared. It smells a lot like a sine squared. It's like cookies. It's like cookies. Okay, and then in the bottom, we're just left with 3 times sine and sine. I get 3 sine squared of t. Oh, this one's going to turn out to be nice. 1 minus cosine squared. 1 minus cosine squared. Remember, sine squared plus cosine squared is 1. So sine squared would be 1 minus cosine squared. So this is the same thing as sine squared of t all over 3 times sine squared of t. Oh, how fun is this? These sine squared cancel each other out. Still think there's a 1 times here. This is all just 1/3. What? All along? All along, this was just 1/3. Why didn't you tell us from the beginning? Why didn't you tell us from the beginning it was 1/3? Oh, that is just fun. That is just good old fun. Okay. Let's see here. Why not? I have one more example that looks fun to do. Let's go ahead and do one more. Okay. We have a. My notes say we have a sine of t, a sine of t, all over a 1 minus cosine of t. How about minus a cosecant of t? Okay, go ahead, pause the video, give it a shot at cleaning this one up here. Okay, let's do it. Okay, first thing that's screaming at me to do is to add these fractions. I'm going to turn that cosecant into a 1 over sine. So here we have a sine of t all over a 1 minus cosine of t minus, this is the same thing as 1 over sine of t. Okay, cool. Okay, what we're going to need to do here is we're going to need to add these fractions. So we need to find a common denominator. So let's hit this one with a 1 minus cosine of t all over a 1 minus cosine of t. And over here, how about we hit this one with a sine of t all over a sine of t, so we can add these fractions. Okay, what are we going to get here? In the numerator, we're going to get a sine squared of t. Okay, we need to be careful with parentheses here. This is minus, I'm minusing this entire quantity, minus a 1 minus cosine of t. So make sure we're putting parentheses. Okay, all over. Well, what's our common denominator? What's our common denominator? We have a common denominator of sine of t times a 1 minus cosine of t. Okay, I could see a lot of tempting mistakes here. I could see a tempting mistake would be thinking to cancel this 1 minus cosine t's. We can't, because these are separated by subtraction. These aren't factors. You can only cancel common factors, not common terms. The reason why we can't cancel these is because of this minus sign. Everything in the numerator is not in terms of multiplication. So the only thing I can really think to do here is cleaning up the numerator by distributing in this minus sign. So if we distribute it in that minus sign, we'll get a minus a 1, and then we'll get plus a cosine of t. Okay, now what to do from here? Well, I do see this sine squared here, and I do see some cosines. So, I mean, I'm going to try to use a Pythagorean identity here to maybe clean this up a little bit nicer. Okay, let's recall that sine squared of t plus cosine squared of t is equal to 1. Okay, so what can we do here? Well, I guess we could see that sine squared is the same thing as 1 minus cosine squared, or you could say that sine squared minus 1 would be the same thing as negative cosine squared. However you want to do it, I'm going to write this sine squared. I'm going to rewrite sine squared. How about we just say sine squared is the same thing as 1 minus cosine squared of t. And let's see if this cleans up a little bit nicer here. So that's what we'll do. Okay, so this sine squared of t is now going to get replaced with a 1 minus cosine squared of t. So I'm going to go ahead and erase this right here. Just made this nice replacement. Okay. Well, why was this kind of useful for us? Well, I have a 1 here, and I'm subtracting a 1, so these at least cancel. So it looks like we have a minus a cosine squared of t plus another cosine of t. All over, we still have the sine of t and then a 1 minus cosine of t. Okay, what can we do here? Well, when I'm looking at this numerator here, we could maybe kind of notice that we have a common factor of cosine that we could factor out. I think it's going to work really nice for us. So we have a cosine of t, Okay, then what would I have? I'd still have a negative cosine left, a negative cosine of t, plus now a 1, all over a sine of t times a 1 minus cosine of t. Okay, cool. Okay, well, negative cosine of t plus 1 is the same as 1 minus cosine of t. So notice that these, now it's all in terms of multiplication, these are common factors that can cancel out. And what do you know? This is the same thing as cosine over sine. It took us a little while, but we got there. This is the same thing as cosine of t all over sine of t, which, what do you know, is the same thing as cotangent. No, silly cotangent in disguise. Silly cotangent in disguise. This is all the same thing as cotangent. Cotangent of t. And here's the answer. Okay. This one was a little bit spicy. Had to throw some Pythagorean identities in there. So, what can I say for these problems in general? You know, you're going to be wanting to write, in general, you can always kind of write things in terms of sines and cosines. That should always work out for you. Sometimes that could be a little bit of a longer route. I would say have fun with these. Try to be creative. Try something, one way. Maybe you saw a different way you could do it. Maybe try it a different way. And then you kind of learn from those experiences, maybe which way you thought was easiest to work with. These are all just fun little puzzles, So just, have fun doing them. Ask lots of questions. Get lots of practice. In the next video, what we're going to be doing is we're going to be proving trig identities, which is a very similar exercise to what we're doing here, but it's a little bit more guided. Okay, we'll see you there. Take care.